Hey everybody, welcome to another Probably Private. I'm Catherine Jarmal, and today we're going to talk about LLM parameter tuning. What does that mean? Temperature, top P, top K. You've seen me kind of reference these in config files. Check out my Llama CPP video for how you can set these and run these yourself on your own LLM server or GPU-based server. But I want to try to give you some intuition around using these for your work with LLMs, whether you're using them at home or whether you're using kind of third-party AI vendors. And I want to touch a little bit on how they relate to concepts like privacy and security. Okay, let's hop right in. First, let's talk about what these exactly do, at a high level. So we're going to talk about temperature, top P and top K, and that they could basically control the probability distribution at each prediction step. So with LLMs, we know we're going token by token, and the context that we're using is all of the tokens that we've processed up to the point that we're deciding the next token. And so these control exactly which tokens we might select next at the very last stage based on all of the activations that we have from however much context, system prompt, user prompt, and then however much the LLM itself has already wrote as part of its answer. So all of that precedes this and helps decide what's that probability distribution. And then these little things, these parameters let us tweak what we think it should change in that LLM system to predict the next token. So basically it's asking the questions, how sure do we want the model to be before picking the next token? So we can try to make it more sure. We can try to influence it being a little bit less sure of the answer. And these are ways that we can put our own inputs and also compare depending on our use case, which we'll get into in a second. The lower it is, the more deterministic, predictable, and as you already know, if you've been watching this channel for a while, maybe memorized. So if you're doing privacy attacks and you want to extract memorized data, setting temperature to 0 is a great way, or 0.1 or something like this, is a great way to increase the chance that you can extract memorized data. If you're new to what does she mean, memorization, check out my series on memorization in deep learning systems. And if you turn up these things, you're going to get maybe creative, surprising, and maybe wrong answers. So if you work in security, you're probably like, because maybe you also want more that memorization element than you want LLM decides. It doesn't decide, but the output becomes kind of unwieldy, less predictable, potentially more prone to security problems, depending on what it is you're using it for. And so let's take a look here. We have our logit layer. In deep learning, usually our logit layer is our second to last layer. And that's going to have like a bunch of weird math, right? Like logits do not make sense. They're not on a scale. We can't really use them directly. I mean, we can use them for some things. Stay tuned on differential privacy with logits, but we don't usually touch the logit layer. Usually we send it through an activation function, and that activation commonly is something like softmax, or there's like a bunch of different activation functions. I'll actually put a link in the notes for you to look at different activation functions. But for most of the part, you're using an LLM that's probably using softmax or some similar function. And that's basically taking these logits and scaling them to, softmax is a little bit like this, scaling them to something that we can then decide what is the probability of activation point 0, 1, 2, 3 on some sort of reasonable distribution. And that ends up being that final layer that we use that says like 40% chance the next word should be A, 30% chance the next word should be the, and. And so this is basically take it from deep learning math into human translatable probability distributions that we can then pick from and say, actually, we want to do this. And essentially what these LLM parameters do is it lets us control that activation function when it comes to temperature, or the resulting probability distribution that comes out of that function, which refers to top P and K. So we're basically messing with these last two things in our deep learning. Okay, so what does temperature do? I'm going to show a little bit of math. Don't be worried. I got you. Okay. So basically that softmax, so the E here we use as a constant. It's the E that you remember from your graphing calculator, if you remember those days. If not, then it's just the math E you can import in Python. It's Euler's constant. So this is just a constant. Why do we use that? A, because it's good for the type of math we do in deep learning. B, it ends up creating some non-linearity, which basically means like we can learn things that are more complicated than traditional machine learning, which is also why it loans itself to things like deep learning, the type of math that we do in deep learning. And then this little Z is essentially going to represent our activations, right? And the temperature here, you can see acts as a regularizer. So already we have kind of like this constant to the logits over all the logits, so the sum on the bottom, right? So that's basically saying like push the ones that are more likely further up, push the ones that are less likely further down this curve, you can think of it as. And then the temperature basically is like, and how much do you want them to play with each other? Like one being, that's the normal softmax. So temperature one being, that's what we used to do pre-temperature. I mean, temperature's kind of probably been around for a while, but before temperature was so popular in these softmax activations, right? And then lower being like, we're going to scale it down. We're going to make it even more predictable. And then higher being like, let's make the curve wider. Let's let more people come to the party. So that's me trying to summarize it well. If that worked for you, let me know in the comments. If you have questions, also let me know in the comments. So we can think of temperature on some sort of scale here. We can think of 0 again, or 0.1, this type of like very low temperatures being like highly deterministic, right? We can think of, because it does scale there, it's not exactly divided by 0, obviously. We can think of 1 being a normal softmax, so kind of like what we would think of like standard machine learning, standard deep learning prediction, so not playing so much with temperature. And then we can think of like 2 and above starting to go more into wild style. So let's take a look together. Let's play around. Okay, now I'm in my Llama CPP. This is the front end that gets launched as part of when you're running Llama CPP servers. I just wanted to show you a different view of Llama CPP today than in the terminal or in a Jupyter notebook. And I have my initial prompt here. I want to try a new recipe tonight. What will you suggest? I don't want it to take too long, but make it tasty and interesting. I'm using Qwen 3.5, 35 billion parameterized. And then I can click on this little symbol over here, and I can look at sampling, and I can set temperature. So we'll just go with the default that comes with Qwen, which is 0.8. And we're gonna send it and let it run. Okay, so we got some good suggestions. We got shakshuka, Korean beef bowl, lemon garlic, butter, gnocchi with shrimp. We can look through the reasoning tokens if we wanted to, but here's our basics. Okay, now what we're gonna do is I'm gonna copy that same thing and we're gonna bump up the temperature. Let's see what happens. Let's make it, we're just going wild here. We're going temperature 2.0. Actually, let's make it even wilder, right? Why stop? Technically, I've even seen people use temperature 10. I don't know what those people are doing. There's some craziness. If you use temperature 10, let's go 4.2. This is a good number. All right, so let's send that over. It's running through. If we get the same answer, I'm going to be very disappointed in Quen's training data. I don't think we'll get the same answer. All right. Now we got gremolata salmon asparagus. Interesting. Actually, that doesn't sound too bad. Thai peanut boat noodles. I don't know what makes the boat part of that. Maybe a wild token got in there. If not, let me know. And then we got Cajun shrimp sausage skillet. So this is like, it probably actually appended the previous conversation. So unfortunately, we kind of like poisoned. If this was a real experiment, I would have opened a new window and started it. But hopefully this gives you an idea of tinkering with temperature, which you can do directly in most of the UIs that you use. And also, if you're sending over your request directly, you can add it essentially to your request data. All right. So let's go into the other things. You had some fun with temperature. Let's talk about top P. Top P is sampling from the top P percentage of the probability mass. So that means between 0 and 1. So 1 being 100% and everything else being some version of that. And the cool thing about top P, why I recommend tinkering with it for your use case, is that it's going to change per token. So as you're predicting along, sometimes the next token is really, really heavily weighted towards one word or one symbol. And then sometimes it's less sure. The Logit layer itself is I don't know, could be any of these, 200 things. And playing with top P lets you kind of add a little bit more determinism, but it's not overly restrictive. And here I just have a little bit of a visual example. Again, you can play actually with top P in the Llama CPP. And lots of models come already with a recommended or a default top P, just to let you know. So top P, I want, let's say 0.85. So 85% of the overall cumulative probability is what we call it. But so you can think of take 100% would be all the next tokens that have above 0 probability. And then you just take the ones that end up adding up to 85% based on their unique percentages. So here I want to, the, a, my, his, whatever, right? This is just an example. So finish the next token. So that's that. And, again, you can play around with this and I'll go over some use cases. But finally, I'm going to cover quickly top K. This is literally a hard cutoff. It's going to say we only take K tokens and we stop there. It is not dynamic at all. And your model probably already has this. Basically, by default, every model has some top K because those Logit layers start to get smaller. So by default, the vocabulary size is shrinking near the end there. And then usually the model itself or the model serving already has also an extra cutoff for speed, efficiency, just also because it makes sense from a memory standpoint. In general, I would say just use whatever top K your model has. If you want to tinker with it, do, but I would say play with top P before you play with top K. So let's say I wanted to be really restrictive and a top K 3, this is that same distribution, it would literally just shut off every other token, right? So again, a pretty hard knob, probably not useful for most people. Maybe you have a use case. If you have a use case for top K, let me know in the comments. So let's walk through some use cases. There are some types of tasks we use LLM for where we really want it to be correct. I would say this is things like writing code, It might be scientific concepts or mathematical concepts. You want to have a low temperature, and you might play around with lower top P or K. You don't have to, though. You could just start with temperature, and that will do it auto-magically, so to speak. Now, remember, the chance that you might end up with some memorized data is non-zero, okay? So just FYI. Then you want maybe in the middle, I would say this is reports, emails, maybe normal, like transcription, but other tasks where you're kind of just doing quote unquote normal LLM work, whatever that means for you. Then you might want to keep the temperature around 1, so like give or take. And you might want to reduce the top P somewhere in the 0.8 to 0.9 range. I've often seen recommended, but you should probably tinker with it yourself if you want to touch that, or if you just want to take the model defaults, right? Because sometimes the model providers are already telling you, this is what we think the like average use case is. And perhaps that's a good idea to use. Or you just go wild. So you might want to do creative writing. You might want to do wild ideation. You might just be doing security research, tinkering with stuff. Then I would say bump it up just to see. And let me know how it goes. And for this, if you're really doing go wild, like don't set top P or K, unless the model has a really restrictive one there. So if the model defaults have a really restrictive top P or K, you might want to turn that off, set higher levels. So top P, obviously the highest you can go is 1. K, it probably depends on your serving how high your K can be. So take a look and figure out what is the maximum K you can set. Okay, so check out my notebook. I got a notebook, this little tidbit from it. But in that notebook, I take you through setting up a prompts template and then tinkering and literally looping through these, saving them to a file, which you can then use to evaluate, label, review. Or if you're already using something to label your data, you might want to set up a task that goes through these when you're starting a new use case and start to get an idea, hey, what's going to be the best temperature for us for this? Do we want to set top K? Do we want to set top P? Here, obviously, top K this is probably not a good default. It was more just for demonstrative purposes. Also, those top Ps I would probably never use other than the 0.9 and maybe the 0.7. But this just give you an idea. Set those ranges yourself or set the values you want to test yourself and then go with that. Let me know how it goes if you experiment with the notebook or if you try this out in whatever interface you use. And tell me, if you're willing to share, tell me what values work for what use cases that you're using LLMs either at home or via third-party services for. Because again, the more that we share, the more we can compare and learn from each other. If you like this video, think about liking it, think about subscribing, and let me know what else you'd like to learn. See you next time.